This is the video solution to practice problem A that accompanies sample problem 1.8. This problem appears on page 24 of your textbook. This problem is pretty typical of a dimensional analysis problem like you might encounter in TASL or on a quiz or test. We're given a little bit of information at the beginning to put the problem into context and then asked to carry out a conversion. There's no mathematical equation for converting between milligrams and ounces, so we should use dimensional analysis to solve this problem. Let's think about where we need to end up first. The question asks us to convert mass to ounces. When we're finished, our final answer is going to have to be in ounces. Our starting point looks like it will be the value 300 milligrams. Our basic process then will be to begin with 300 milligrams. But where do we go from there? The problem gives us some information about what an ounce is equal to, but that information doesn't involve milligrams, and we're going to have to cancel milligrams in our first conversion factor. The milligram is a unit of mass that can be converted into any other metric mass unit. We can easily convert milligrams to grams, and then, in another step, we'll use the equality given in the problem to convert grams to ounces. And at this point, we have a kind of roadmap that we can use to solve the problem. Each arrow represents a conversion factor that's specifically set up to cancel one unit and leave us with another. As we go through the problem, we'll underline the last significant figure. We're told that the value 300 milligrams has one significant figure, so we will underline the 3 in this measurement. Our plan was to convert milligrams to grams in the first conversion factor. If you aren't that familiar with the metric system, you can look at your exam information sheet and find out that 1 milligram is equivalent to 10 to the negative third grams. Notice that the equality in the exam information sheet doesn't show the grams, but whatever base unit we need on one side of this equality has to be put on the other side as well. From this equality, we could potentially write two conversion factors or fractions. One would show 1 milligram as the numerator and 10 to the negative third grams as the denominator. The second conversion factor would show 10 to the negative third grams as the numerator and 1 milligram as the denominator. Our goal was to cancel milligrams at this point, so we'll use the second fraction as our conversion factor. Let's move that into place. At this point, our milligram unit cancels, and the unit that remains is grams. We decided that the next step was going to involve converting grams to ounces using the equality given in the problem. From this equality, we could also write two conversion factors, one with 28.3459 grams in the denominator and 1 ounce in the numerator, or the reverse. Since we need to cancel grams, we should use this first fraction in this conversion factor. And let's move that into place. This obviously allows us to cancel the grams, leaving units of ounces. Our units all cancel. The next thing for us to do is to run the values through the calculator. In the numerator, we have 300 times 10 to the negative third, and we have 28.3459 in the denominator. When that mathematical process is carried out, my calculator says that the correct value should be 0.010583541 ounces. Well, finally, we need to think about significant figures. Our original value had one significant figure, and we can't write a value with any less than one significant figure. So in this case, it really doesn't matter how many significant figures are shown in the conversion factors. We only carried out multiplication and division to solve the problem, and that means that we'll round our answer to reflect the fewest significant figures, or just one in this case. Therefore, we'll round between the 1 and the middle 0, the sandwiched 0, obtaining a final final solution of either 0.01 ounces, or if we were to write it in scientific notation, 1.1 times 10 to the negative 2 ounces. Please take some time to look at practice problem B in this section and check your answer on page 33. As you go through the problem, don't forget to show your work and record units every time you write down a number. If you have any questions, consult your instructor.